Hello friends, I welcome to you in your YouTube channel Physics and You. Today I am here to discuss a new animated video related to Nd-YAG laser. Let's start the animation. Nd-YAG laser is firstly demonstrated by J.E. Joyce in 1964 at Bell's laboratory. Nd-YAG laser is generally a solid-state laser and it is a 4-level laser. Nd-YAG laser required a optical pumping for the excitation of neodymium ion, and that can be achieved with the help of xenon and krypton lamp. In Nd-YAG laser, optical resonant cavity has been made with the help of partial coating mirror and M1 and fully coating mirror M2. Nature of output is generally continuous in nature. Output is 106400 angstrom has been produced. In Nd-YAG laser, most important component is the Nd-YAG crystal, which was formed with the help of neodymium doped yttrium aluminum garnet. You can see the formula of 1% doping of neodymium in yttrium at 25 degree centigrade, where YAG is behaving as a host and NDY3 is behaving as an active center. In right hand side, you can see the systematic diagram of the Nd-YAG laser, in which you can see resonant cavity at both ends of the crystal. One is partially coating mirror M1 and a second is called as a fully coating mirror M2. Flash lamp is around the Nd-YAG crystal. That flash is also connected to the power supply. Output is generally taken from the partially reflecting mirror whenever it will be achieved, and wavelength 7200 angstrom to 8000 angstrom is generally produced through absorbed by the neodymium ion when the flash has been owned. So as we have already discussed about the resonant cavity, you can see, so NDY optical cavity is most essential part in the any laser. Okay? It is a working of the Nd-YAG laser, where you can see a 4-level system. E1 is representing a ground state where number of atom has been represented as a green color circles. Excited state is the E4. When the flash has been produced, from that flash particular amount from the 7200 angstrom to 8000 angstrom get absorbed by the neodymium ion. They absorb the energy and move toward the excited state. But that excited state is completely unstable state, because lifetime of that excited state is 10 raised to minus 8 seconds. That means the excited atom make a transition from E4 to E3 within a very short span. This transition is generally called as a non-radiative transition, and that intermediate state is called as a metastable state. Metastable state is generally called as a long-lived state because atoms stay here for the longer time. Time duration is 10 to the minus 3 seconds. When the atom get accommodated in E3 state at the time when, now here, optical source is on, if there will be a ground state atom present, they move toward the higher state. Atom present in a metastable state make a de-excitation to E2 state. That first de-excitation is spontaneous by emitting 1064 angstrom, and that photon again stimulate the atom present in metastable state and induce them to return back to ground state by emitting same photon of 1064 angstrom, and this is producing a laser action, and it is the entire working of the Nd-YAG laser. Again you can see atoms are again present in a excited state E2. Okay, so that means they still want to return back to ground state by making a known less radiative transition to E1 state. So one by one they de-excite and return back to ground state. Now that means it make a continuous mechanism from E1 to E1. Here it is representing a less radiative decay from E2 to E1 state. This is the entire circle of your Nd-YAG laser. The rest of the thing, it is a continuous mechanism. It is an atomic level process. So it is in a sequence. It is again, if atom return back to ground state, they again absorb the energy from the optical source and move toward the E4 state one by one. Okay. Then what happen? They get accommodated in a excited state, but that excited state is again unstable state. That means it again return back to ground state E3 and making a continuous mechanism. Hope you like the video. If you like the video, hit on the subscribe button. Thank you very much. Have a nice day.